Mankind has always looked to the stars. Since time immemorial, the universe has been a source of fascination and fundamental questions. What else is out there? How was all this created? Where do we come from? It is our constant companion and has always held a very special fascination for us, the Moon. We have sent probes to it and man has even set foot on it. On July 20th, 1969, Neil Armstrong stepped onto the Moon's surface. 5 further manned missions were undertaken to the Moon. The final footprints in the moon dust were left behind by Eugene Cernan. That was in December 1972. Welcome to Spacetime with Ulrich Walter, astronaut and scientist. He knows, in space, incredible things are in store for us. Man wants to return to the Moon. It's like a lost love, reawakening. All space nations are considering manned missions to the Moon. China, Russia, America, but also Europe, Japan and India. Probes are surveying and monitoring the Moon more intensely than ever before. The aim is to go deeper into space, perhaps even to Mars. And for such a mission, the Earth satellite would be the ideal training ground. It's only a matter of time before man once again sets foot on the Moon.
What? To the Moon again, some may ask? We've been there already, 50 years ago. That's of course true, but in the meantime, a lot has happened. We now believe, for instance, that there's ice at the poles, and ice means water. And water's good for enabling people to live on the Moon. We also believe that the Moon has a certain inner structure. But we don't know for sure. For that reason alone, we need to go back to the Moon. Competition. Competition is good for space travel, because competition stimulates business.
While in the 1960s, the race to the Moon grew from the seeds of the Cold War, the new endeavors have a more scientific character. The Moon is being re-explored, surveyed and mapped. A research station on the Moon's surface would be the new outpost for humanity in space. And the Earth satellite is an attractive prospect for investors.
The Moon can be reached relatively quickly. You can get there and back in a week. And that's why you can do a lot of things in the Moon that would help us progress. Development of technology, science, but also as a stepping stone, a springboard for probing deeper into space. So there are many aspects of the Moon that would be useful to us.
The Moon is only a 3-day journey from the Earth. It's the perfect place for testing out new space technologies. Rather than just landing there for short visits, astronauts are to stay there long-term and work on research projects.
It's rather like stepping outside your front door. The Apollo missions were carried out back then to demonstrate that we can do it technologically. In that case, the Americans. But if you want to go to Mars, you have to do a lot more. You can't just fly to the Moon and say, look, we've done it. You have to show that a link between the Earth and the Moon can be created. For instance, that a research station can be established, where people can live for several weeks or months.
The International Space Station is currently mankind's scientific outpost in space. The world's greatest technology project is operated by an international community of space nations. The space laboratory, however, is approaching the end of its service life. New goals are being considered, and increasingly scientists are placing their focus on the Moon. In 2007, the X Prize Foundation launched a competition for the first private landing on the Moon, with the prize money donated by Google. The task is to land a rover on the Moon, which can then transmit images back to Earth. Such competitions have a long tradition. In 1919, the hotelier Raymond Orteig offered a prize of $25,000 for the first non-stop flight from New York to Paris, which was eventually won by Charles Lindbergh after his historic cross-Atlantic flight. The prize sponsors want to create incentives for the development of new technologies and business fields, completely independent of state institutions.
Google will pay $20 million to whoever achieves the first soft landing on the moon's surface and sends images back to Earth. But what's that in comparison to the total expense of such a mission? Look, the launch costs alone amount to somewhere between $30 million and $50 million. And then the costs for technology. You need engines that work properly. Only the leading space nations have them, and they cost a lot of money. And they have to be controlled properly, so you need very good software that you have to develop yourself. And this software has to see whether there's anything up there on the moon I can't land on. If your landing craft lands on a lump of rock and tips over, that's it. Or the hatch on the lander doesn't open and the rover can't get out, then that's it too. So, there are thousands of little things that such a mission depends on. Although, the people in the team are all highly motivated space engineers. They know exactly what they're doing, but mistakes can always happen anyway. And that's why I believe that all these teams involved in the competition, perhaps only one of them will actually win. But to be honest, that's not what it's all about. Just like the Olympics, it's not about winning, but about being part of it.
Teams from Germany are also taking part in the competition. The most promising candidates came from Berlin. Young people who want to fly to the moon.
I just found the idea so incredible that as a private individual, you can say, I'm going to build something privately financed, that I can send it to space and fly to the moon. And that's what gave me the incentive to sit down with friends, acquaintances, anyone I could find, and discuss the idea. Does it make sense? Is it feasible? Do you have to be NASA, or can you actually do something like this on a private basis?
The space startup from Berlin developed and constructed the prototype of a moon rover. With this, the company won one of Google's coveted milestone awards. $750,000 that were invested in building up the business. Meanwhile, the young enterprise has dropped out of the competition and is now working on the moon landing project under real market conditions.
The most difficult part of deciding when you're actually finished is taking the design tool away from the engineers and saying, this is what we're doing. Because engineers are never finished. We decide by saying there's a certain risk that we're prepared to accept. Let's say a 20% failure risk is okay. Then we look at the failure probability for every component. And as soon as we arrive at the 20% mark, we say, okay, now we can start.
The landing module and the rover are currently under development. The system will be launched into orbit by a commercial rocket. From there, it will head for the moon under its own power.
When Kennedy first proclaimed the goal of putting a man on the moon in the 1960s, it was a time when there weren't even the right rockets. NASA first had to develop ways of putting people into space at all, and proverbially speaking, they still wondered whether the moon was made of cheese. Today we live in a time of high-resolution maps. We have physical data from the moon and all the Apollo material. Now we have the rockets, we have the engines, so it should be much easier. That was the thinking behind it. The decisive point, however, is that it's the mixture of knowledge and experience that's important.
Thanks to the Apollo missions and technological advances, an unmanned moon landing is certainly feasible for private companies. Not cheap, but within the realms of possibility. It is a completely new approach to conquering space.
The way I see it, returning to the moon on a private enterprise basis is the key to future space travel for the human race.
The moon is there, and scientists, researchers, or even gold prospectors will grasp the opportunity to set foot on its surface again. The moon has an abundance of resources, and the existence of frozen water has also been proven.
Die Rohstoffe sind auch ein weiterer Grund, warum natürlich jetzt die Aufregung.
The raw materials is another reason why the excitement has returned now. It first has to be said that we've known for some time that the moon consists of 40% oxygen, so the moon has always been of interest as a destination, and for the raw materials as well. But the discovery of water on the moon has raised this to a completely different level. And water is, of course, wonderful. You can make rocket fuel from it by splitting it into hydrogen and oxygen. You can drink it. And when you split it, you can breathe it in the form of oxygen. So the discovery of water has given the whole thing a real boost.
There's no erosion on the moon, no wind or rain to alter the surface. A witness to the creation of our solar system.
If we look at the moon today, we see countless craters, mountains, and also flat, even surfaces that look as if they've been flooded. Not very rugged at all. And it shows us that the moon has a history. The moon has a history in that objects have crashed into the surface, that there have been lava flows there, and impact grazes. There are these long valleys we think were created by bodies flying through them, making space for themselves.
The moon is so very close to us, not only as a neighbor in the vast expanse of infinity. Its history is also the history of our Earth.
The origin of our moon is a really unusual story in our solar system. So I'll tell it to you now. This is the Earth about 4.5 billion years ago. And about 60 million years later, something really extraordinary happened. A so-called protoplanet, a kind of embryo planet, hit one side of the Earth and tore a huge chunk out of the Earth's surface. The rock and debris this caused gathered in the form of a disk around the Earth at a distance of about 20,000 kilometers. On this scale, that's about this far. And this ring rotated only for a few thousand years and eventually formed the moon. So now something really unusual happened. Due to the tidal forces between the Earth and the moon gradually began to migrate outwards, about 3 centimeters per year. And we can still see this migration today. And so, over time, it migrated outwards to its present position about 380,000 kilometers from the Earth.
July 16th, 1969, Apollo 11 lifts off on its way to the moon. For the first time, human beings are to set foot on its surface. A journey to the moon, not in a novel, not in science fiction, not in a film, but in reality. It's the greatest adventure in human history. The space capsule covers 400,000 kilometers in just under 3 days. This really is man advancing into space. The lunar module Eagle separates from the command module. On board are Neil Armstrong and Buzz Aldrin. Michael Collins remains in the command module.
The race to the moon was purely political. They just wanted to be the first to land on the moon. That was, of course, the goal, to be the first human being to set foot on another celestial body. Naturally, putting the first man up there was also a project of enormous prestige, that a country could say, we have developed this technology. The Americans prioritized this over everything else, and so did the Russians.
The Eagle flies towards its landing site, Mare Tranquillitatis, the Sea of Tranquility.
Contact light. We copy it down, Eagle. Houston, Tranquility Base here. The Eagle has landed.
It's the 20th of July 1969, 1332 Coordinated Universal Time. Place, Sea of Tranquility, on the moon.
That's one small step for man, one giant leap for mankind.
15 minutes after Armstrong, Buzz Aldrin also steps onto the surface. the most adventurous space enterprise ever undertaken. The first walk on the moon.
You have to realize the Americans achieved this in 8 years. From the announcement in 1961 to 1969, landing on the moon, 8 years had passed. 8 years, that's not very much time. Think about this. In North Rhine-Westphalia, it took 10 years to build the Westhofen Autobahn junction. So building a highway junction is apparently more complicated than landing on the moon.
The Americans traveled to and landed on the moon a total of 6 times.
Roger. All dressed up and no place to go.
The final mission was Apollo 17 with the astronauts Eugene Cernan, Ron Evans and Jack Schmitt. On December 11, 1972, Cernan and Schmitt landed on the moon in their lunar module Challenger. Besides the obligatory American flag, these last visitors to the moon also left their moon rover on the surface. And that's precisely where the Berlin space entrepreneurs want to land, to examine the Apollo 17 vehicle.
We want to see if it's been shot to pieces by micrometeorites, or whether the radiation has decomposed it, or if it's covered in dust. If yes, then why? If not, why not? These are the questions we want to answer when we get near Apollo 17.
The moon buggy left behind by Apollo 17 is an historical relic and technically still the property of NASA.
There's some scientific benefit to returning and analyzing it. And there's also the chance you could destroy something if you're careless. So you need to find a balance, and we can't decide that alone. So we've been working that out together with NASA.
The last men on the moon left their buggy there and brought rock samples back in return. And in these samples of moon rock, traces of water were discovered.
Is there anything on the moon that could support us in our attempts to survive up there? And now we have actually succeeded in finding water at the poles, in craters the sun never shines into. So the next thought is, if the rock contains water and we can extract it, there'll be a water supply enabling people to survive. A place the sun shines on is several hundred degrees in temperature. Anywhere it doesn't shine on, maybe only 2 meters away, is minus 200 degrees. This light-dark contrast is enormous, both in temperature and in radiation.
These extreme conditions make developing a moon rover so complex. Every component has to operate reliably on the moon's surface.
The greatest challenge is the lunar night. On the light side, the surface temperature is 120 degrees Celsius, which is manageable. When the sun sets, the temperature drops to minus 180 degrees Celsius. So that's the big challenge. How to get materials to withstand these temperature differences between 120 and minus 180 degrees Celsius. Then there's the other problem of radiation. When you're close to the Earth, like the ISS, the Earth's magnetic field protects you from radiation. On the moon, that's a luxury you don't have.
For any long-term stay on the moon, the question of water is particularly important. To verify its existence, but also to survey and photograph the moon precisely, NASA sent its Lunar Reconnaissance Orbiter to the Earth satellite in 2009. Orbiter is still flying over the moon today, at an altitude of only 20 kilometers. It provides high-resolution images and maps, and its sensors search for water.
We now know that there's water on the moon. Who would have thought it? And in 2 different forms. A few years ago, the Americans launched their so-called LRO mission, and over the entire surface, they discovered a little water. The Americans say it's about as much as in the Sahara Desert at night. That means there's only a monoatomic layer of water, so it's of no use. But importantly, things get interesting in the craters at the North and South Poles. Why? Well, the sunlight never shines into the poles. It only crosses them horizontally, and that's why water has formed there, due to the impact of asteroids and comets over millions of years. And that still exists, even at minus 250 degrees Celsius, and it means that if we undertake a manned mission to the moon, we've got to go to these craters because there we have ice, and from ice we can make water and survive.
In moon matters, it's the Chinese that are currently most active. The People's Republic of China has started a multi-phase moon program. Phases 1 to 3 include an orbiter, the moon rover Jade Rabbit, and a mission to bring samples back to Earth. A possible fourth phase could well involve Chinese taikonauts landing on the moon.
Should China's moon plans be taken seriously? Well, if you ask me, then definitely yes. At the end of this year on their Chang'e E5 mission, they not only want to fly around it, they intend to land and bring rock samples back to Earth. That's really very sophisticated. So far, only 2 space nations have managed to do that. The Americans with their Apollo missions and the Russians in 1976. That's not widely known. They sent an unmanned craft to the moon, collected 100 grams of samples and returned with them to Earth.
The Americans put the first man on the moon, but the first vehicle on the moon was of Soviet production. As part of their lunar program, the Soviets sent Lunar-1 to the moon. The size of a small car, this vehicle weighed 750 kilograms and was a laboratory on wheels. On the morning of November 17, 1970, at precisely 6:47 Moscow time, Lunar-1 made a textbook landing in the dust of the Mare Imbrium. The robot collected and analyzed countless samples and sent 20,000 images back to Earth. And the Russians also want to go back to the moon. Together with the European Space Agency ESA, a mission is planned to explore the lunar South Pole. The objective is to drill for water, while at the same time investigating conditions for a possible research station.
The collaboration with Roscosmos will involve the Luna 27 or Lunar Resource Mission, which will probably land on the moon in 2021 in the southern polar region and take samples there, using a drill which ESA will supply. This will then extract moon rock from a depth of 2 meters. This isn't then delivered back to Earth, but analyzed then and there.
The landing site is the South Pole Aitken Basin, a giant crater on the far side of the moon. The basin is the relic of an enormous asteroid hit, and it's believed that this asteroid also brought water to the moon.
Of course, the moon is very exciting, always has been. Interestingly, one reason why it's becoming exciting again is that we understand more and more the importance of these moon samples, which were brought back by Apollo. We've learned, for instance, that at one time the moon was completely molten and the entire surface was covered by an ocean of lava.
Oh, swear not by the moon, the inconstant moon that monthly changes in her circle orb, Juliet tells her beloved Romeo. But among space travelers, it has awakened new desires. In their quest to penetrate deeper into space, they have rediscovered the moon as an ally.
Wouldn't it be just as good to build a lunar station that just constantly orbits the moon? No, it really wouldn't, because we actually need a station up there to find out whether there really is ice at the poles. To do that, you actually have to be there. Or if you want to find out about the inner structure of the moon, we actually have to take seismological readings on the moon itself. That's the one reason, but there's another perhaps even more important one. In the 1950s, aerospace engineer Kraft Erike once said, "If God had wanted man to become a spacefaring species, is, he would have given man a moon. What he meant by that was, we need a moon if we want to advance further into the depths of the universe. That's where we can test whether we have the technologies under control. If we want to go to Mars, we'll have to practice on the moon. So the moon is no more than an interim step on the way to our long-term goal, which is Mars.
The International Space Station has meanwhile proven that human beings can live for long periods in weightlessness. Some crew members spent up to a year in orbit. But a journey to Mars would take several years, and explorers would be exposed to quite different dangers that can't be simulated on board the space station. A struggle for survival in a radiation-filled environment, far away from the resources of Mother Earth.
The challenge on the ISS of how to survive in a habitat orbiting the Earth has now been met and solved. We're now ready for the next challenge, which is how to survive on another planet. You need to solve the problems of dust, of power generation, and that's how technology can be improved and advanced.
An international station on the Moon would be the next logical step for advancing space research. Having its own village on the Moon would give the aerospace industry an enormous boost. A permanent lunar station would allow current technologies to mature and give rise to new ones. And it would significantly strengthen cooperation between nations on Earth.
Moon Village describes a concept rather than a project. The Moon Village concept is an idea of taking the various actors worldwide, whether private or state, robot or astronaut, bringing them together and coordinating a common cause on the Moon.
Scientists and engineers around the globe are looking into solutions for colonizing alien planets. Whether on the Moon or Mars, long-term human survival has to be guaranteed. Man will not be spending a few hours on some celestial body, but many days, perhaps even years. He needs a dwelling, a habitat.
There are numerous constraints. The harsh environment or the minimal space. The space provided by the transport rocket. What's special about She is that it can be folded. That it consists largely of petals which unfold from a core, doubling its volume. It's not an inflatable module, but transformable by means of these petals. A habitat like She can only be an initial basis, not a long-term habitat. Firstly, because it needs additional components, of course, like a greenhouse. But also because it has to be erected under a radiation-proof shell, so the inhabitants are not exposed to this fatal radiation.
Unlike the Earth, the Moon has no magnetic field to deflect the radiation. This celestial body of debris is a remote, hostile and airless world surrounded by infinite nothingness.
There would always be a supply problem. You'd only be able to take what is absolutely necessary. And I think life there would be very restricted. Maybe it can be compared a little to a station at the South Pole. Researchers living there are in roughly the same situation, except that they don't have the constant fear that they could run out of air.
But before anyone can live on the Moon permanently, living space first needs to be created.
These technologies are currently being developed on Earth. That's what NASA, but above all ESA, is doing, together with the DLR, taking regolith, the moon soil, and then using special 3D printing that we're now also familiar with on Earth to make bricks or even entire structures.
3D printing is a key technology for these missions which are to take us far away from Earth. But the printers too would have to be taken to the Moon or to Mars. And to build accommodation, a lot of printers will be needed. Research is therefore being carried out into machines that, first of all, replicate themselves. In other words, make copies of themselves on site.
Today, with 3D printers, we can do all kinds of things that weren't possible before. You can create tools up there that no one would have thought possible 10 years ago. So for that reason, I believe that with a sophisticated technology, people will manage to survive up there.
Robots autonomously building a base on the moon. The necessary raw materials and energy will be produced on site. Though this may appear like the vision of some science fiction author, work on the technological solutions is already in progress.
The concept is that on the moon, you only need the sand and the sun. There's no atmosphere, which means you can use the sun optimally and bundle the rays to sinter the sand and bake it together. In the long term, that's a very realistic concept to use the materials available on site, to build structures which are strong enough to withstand a pressure-tight shell being blown up inside them, in order to create a base where research can be carried out for a number of years.
An international research station to develop new technologies, with alternating international crews. What planners have in mind is an outpost based on the principle of the Antarctic stations.
The first thing that has to be learned on site is how to make things from available materials, how to build a structure. And the other thing is, if we really do have enough water there that's been discovered at the poles, we can use it to separate hydrogen from oxygen, for instance. And then we can actually produce rocket fuel on the moon. And those things I find very exciting.
But in the background, the journey to Mars constantly determines our thinking and planning. The fuel for a mission to the Red Planet and for the return to Earth must be taken along, an enormous burden that first has to be transported into space.
You'll have to use a lot of energy, and if it's a manned mission, you'll need a lot of supply systems. So it's a good idea to make, in quotation marks, a fueling stop on the moon. That's something that really needs to be looked into again.
The cost of traveling to Mars is an estimated 400 billion euros. No state on Earth could or would want to finance such a mission alone. There is only one way to make interplanetary exploration possible: global cooperation. An international research station on the moon could lay the foundations for such cooperation.
Moon Village is really just an intermediate goal. What mankind really wants is Mars Village, flying to Mars and setting up a habitat there. And that's only likely to happen in the 2030s or perhaps even only in the 2040s.
Conditions on Mars have now been well researched. It's believed that there used to be oceans there, and perhaps even life.
Compared to Mars, the moon is, of course, completely boring. Mars has extinct volcanoes. There are different rock formations. There was obviously liquid water on Mars at one time, which means you can look for it in dried-up riverbeds. And you can always pursue the core question: is there life? You can analyze it very precisely. The moon, on the other hand, is monotonous, and that's why scientifically it doesn't make much sense. The moon can be used as a testing ground for other missions. They need to be undertaken at a reasonable cost, and space travel has a cost problem. So you're first testing, for example, new engines via smaller missions to the moon. At the moment, the moon is a test laboratory, but it could be of much more interest if we really start planning a mission to Mars.
A mission to Mars is now technically possible. The risks, however, are enormous.
If you spend 2 years flying to Mars and then discover that the habitat you've brought with you can't cope with the dust on the planet's surface, you've wasted 2 years flying there and 2 years flying back. With technology you could have tested on the Moon in the space of about a month. In that respect, the Moon shouldn't actually be seen as the springboard for traveling to Mars, but as somewhere to test the technology, like mission operations and everything else you need. So you'll be better prepared for going to Mars.
With his company, SpaceX, Elon Musk is striving for nothing less than the permanent colonization of Mars. And he wants to develop spacecraft capable of flying hundreds of settlers at a time to our planetary neighbor. Mars is marked for colonization, and within 2 or 3 generations, 1 million people could be living on Mars. It's a futuristic vision. But it's the private aerospace companies in particular that are driving developments and the market forward, also with regard to a Mars mission or a return to the Moon. And if manned space travel is to have a future, it needs visions.
Do such private initiatives really make sense? I'm quite convinced they do. Not only the big initiatives, like SpaceX or Branson, but student initiatives as well. Let's take another example, Spacelift. We hold an annual competition at our faculty in which students from all over the world come together and show each other whether it's possible to get a spacelift to work. That's not only a lot of fun, but they also compete with each other. The same thing is happening here. The students' motivation is enormous. They learn a lot, and the best thing is that they will be the engineers of the future.
The Moon as a short-term objective for private science and student research. That's also the basis for the Berlin Young Entrepreneurs business model. Should their mission to the Moon prove successful, they would in future like to provide a reliable Moon transporter service up to our natural satellite.
What we hope to do is make space travel affordable, so that a university that's developed an instrument can come to us and say, we want to test it on the Moon, and for a relatively small fee, we'll take it there, and this university can carry out the experiment. Currently, this is all state-organized and extremely bureaucratic and political. And with our service, we want to provide access to the Moon for countries and universities that haven't been able to get up there yet.
The Moon holds a strong attraction for scientists and researchers, but for gold diggers too. Orbiting our planet is an enormous supply of raw materials. Gold, platinum, and iridium are all believed to exist on the Moon.
Should we be allowed to exploit raw materials from the Moon and everywhere else in the universe? Now that's an interesting question. There is such a thing as the Outer Space Treaty, dating back to the 1960s, which regulates who is allowed to do what in space. And it says that no nation may appropriate any planet, especially the Moon. For a certain Mr. Dennis Hope, that was completely irrelevant. He said, I'm an American, and according to American law, I can take ownership of it. In the 1990s, the so-called Homestead Act was passed, which says that anyone can take ownership of any land that doesn't belong to anyone else, simply by filing an ownership claim at the county court. So that's exactly what Dennis Hope did. He went to San Francisco, asked who the Moon belongs to. No one came forward. So he said, now it belongs to me. And no one objected.
The pursuit of profit from outer space is firing the imagination of private individuals and investors. And even today, companies are already gathering funds to dig for precious metals on the moon or find fuel in space. Their intention is to travel the solar system, exploiting celestial bodies like the oceans on Earth in the search for oil. In Europe, true entrepreneurial spirit is being shown by Luxembourg. The tiny Grand Duchy is planning its future and wants to be a pioneer in space mining.
What can we do, and what may we do in accordance with international law? We've worked together with various universities and many experts and have come to the conclusion that, in simple terms, we could apply the same legislation as we do for international waters. No state is allowed to appropriate such waters either, but nations are allowed to fish there and exploit the stocks commercially.
Water from the moon or from asteroids can be split into hydrogen and oxygen, a huge source of rocket fuel. Manned missions deep into our solar system would need vast amounts of it. A fuel station in space would be far more than just a gold mine.
Some speak of 20 years, others 30 years, until this is commercially possible. I can only say that seen in terms of human history, that's no more than the blink of an eye. What are 20 or 30 years today? Take a look back to the 1970s when personal computers were first developed. At that time, a computer cost $4 million, and no one thought that a few years later, there'd be one in every household.
But state-run space agencies are also thinking about mining raw materials in space and on the moon. If they want to send people on missions deep into our solar system, they will also need these resources.
But if you look more closely at something like this, you have to see it as a kind of raw material basis, so to speak, for the next step into space. You take the raw materials, which are there, and then perhaps make something with them that you can use later on your way to exploring the universe. Then I think it could make sense. But as a mining base to supply the Earth, it's completely impractical.
Extracting mineral resources on the moon for a good dividend on Earth. Science fiction, but entrepreneurs are seriously considering it.
I don't think I would invest in such a company. Perhaps in 200 years' time, but I think it's too early at the moment. It's not worth it. The costs are much too high. I wouldn't invest in the exploration of the moon now. It's just not economical at the moment.
But if mankind one day intends to colonize space, or is perhaps even forced to leave the Earth, it can't be done without the raw materials that space can provide. In the science fiction film Elysium, a rich elite takes flight from an overexploited Earth which is sinking into chaos. Their new home is a megastructure put together in the Earth's orbit, which generates artificial gravity through its own rotation.
Generally, human beings have never accepted limits. So why should we expect them at some point to say, okay, we've explored the Earth. We know it now. So let's stay here and everything's fine. I think the urge will be there for mankind to expand further into space, not just for economic reasons, but for exploration and discovery, and that we will want to do so.
Base Alpha 1, we're on approach, on schedule.
But mainly, it's the moon that has always inspired the fantasy of mankind and of science fiction authors. In the British TV series Space 1999 from the 1970s, the Earth satellite serves as a springboard to the fictitious planet Meta. In addition, humanity abuses the moon as a disposal site for its nuclear waste. The US company Space Adventures has quite different plans for the moon. The travel agency for space tourists has already brokered trips to the ISS for private individuals, and in cooperation with the Russian space agency Roscosmos, it now wants to offer its customers the chance to orbit the moon at around $150 million a ticket. Elon Musk has also announced trips to the moon. His private enterprise, SpaceX, intends to launch tourists on a moon mission, orbiting the satellite once and then returning to Earth. Landing on the moon is not yet envisaged. The flight will be undertaken in the company's own Dragon capsule, a spacecraft developed for transporting NASA astronauts to the space station. The expertise and technology are available, and there's no shortage of highly solvent customers who can look forward to enjoying spectacular and highly exclusive views.
If I were standing on the moon, what would I see of a lunar eclipse? Well, let's take a look by drawing it here. Earth would be here, and the moon would be here, for example. And I would be on it as an observer. That's supposed to be an eye, and back here is the sun. What's the path of the sun's rays? Well, they hit the atmosphere here. This causes refraction, and they bend. That means the blue is taken out and disappears, and only the red is bent towards the moon. And that happens on all sides around the Earth. So I'll draw it on the other side. The blue goes away, and the red enters the eye of the observer on the moon. Those are the sun's rays. So what would I now see on the moon? To show you, I'll just draw the Earth again here. I'm here on the moon, looking at the Earth, and behind the Earth is the sun, which I can't directly see. But what I can see through the path of the rays is that the Earth in the atmosphere has a blood-red ring around it. And I can see that wonderfully with my own eyes. And this spectacle is something really unique in our entire solar system.
Moon and mankind, they have a very special relationship. The faithful companion as an object of study, and at the same time, the projection screen for dreams and desires.
For us, the moon has a great cultural significance. Night is threatening, and the moon is a light in the darkness, so to speak. It's something part of the Earth. It's a familiar neighbor. It protects us in a certain way because otherwise, perhaps, there'd be nothing between ourselves and the rest of the universe.
It was the moon that first gave rise to the question, are we alone? This celestial object that has always simultaneously occupied both astronomers and cultural scientists.
I think it's the proximity, the closeness that makes it the Earth's companion in the heavens. That's what makes the moon so interesting.
Mankind and the moon. This pale sphere in the night sky as a visible goal of terrestrial fantasy. The stimulus for man's desire to leave his own planet. In 1870, Jules Verne described its conquest in his novel From the Earth to the Moon. Unlike the 1902 feature film by Georges Méliès, Jules Verne's capsule doesn't actually land on the moon's surface, but remains in orbit. But film director Méliès allows his heroes to experience what is probably the most spectacular sight of modern times, the Earth floating in space.
The moon as a destination is something of great scientific interest. That's something we constantly need to remind ourselves. The moon is like the archive of our solar system, and anyone with a better understanding of the moon as a geological phenomenon will understand the Earth better too.
The last human beings on the moon were Eugene Cernan and Jack Schmitt. They danced and sang on it.
We're strolling on the moon one day in a merry, merry month of December. May's the month. May, that's right. May is the year of the month.
I was taken by surprise by a pair of roguish eyes. In a moment my poor heart was stole away.
Maybe they had a notion that they would be the last visitors for quite some time.
2,500 feet, 52 degrees.
So when is the next time we'll see someone on the moon? Well, not just yet. Probably in the mid-2020s. And Moon Village? No, that won't be a New Berlin or New Munich, but a small astronaut settlement doing experiments and testing technology. Because the moon is only a first step on the way to Mars. And there'll also be something else, tourism. There'll be a first tourist looking back at the Earth during a lunar eclipse who will see this beautiful planet of ours with the blood-red ring around it. And quite honestly, that's an image I'm really looking forward to.
Man has the desire to head out into the depths of space. He wants to journey through his solar system, visiting alien planets. But he is not quite ready. A research station on the moon would be a beginning. Perhaps a first step, a milestone, not just for science, but for the entire human race. The moon as a base for testing new technologies, but also a place for learning how we can live far away from our home planet permanently.